Once we've drawn a project network, if we want to know how long the project will take, we need to find the so-called early start and early finish times throughout the project. That is exactly what's requested here. Let's look. Consider the EPIC project network from scenario 1A. Oh, right, we drew this earlier. It represents them building a stage for the San Diego Convention Center. Okay, fine. What do we want to do now? It says, what are the ES is early start, EF is early finish, times for each one of these tasks? Early start, that's that, early finish. Okay, so these are like facts that we need to discover for each one of them, because ultimately, how much time will this project require to complete? Oh, all right. Early start, early finish times. Huh? What are we supposed to do? For every task in that project, the one, pictured in this network, each task has a so-called early start and early finish time. What it means is if Epic Scenic Studios is in a hurry, what is the earliest you could possibly start on that task? And what is the earliest you could possibly be finished with that task? We need to determine that for each one of the activities. Now, how do you do that? Okay, some tips. To find early start, early finish times, begin at start. Whoops, S-T-A-R-T. Begin at start. Begin here. You say, okay, why every task attached to start automatically has an early start time of 0. This is like a fact. We begin determining these timings by starting with this fact. Any task that is attached to the starting node automatically has an early start time of 0. And you say, okay, why? Because 0 on a numerical timeline is now. That's what 0 means, right now. If a task is attached to the starting node and you're in a hurry, the fact that it's attached to the starting node is telling you you can start on it right now. You can start on it at time equals 0 at the earliest. Oh, all right. Now, this is going to get us started in determining the timing for all of those tasks, but something we ought to do is kind of get set up for those calculations so they stay organized. We had drawn these nodes rectangular, and we deliberately put the label, like A, B, C, D, in the extreme left-hand corner and the duration in the extreme lower left-hand corner. Now it's time to divide up that shape table style. See what I'm drawing? Kind of like a flag. I'm splitting each node, each rectangle evenly into 2 rows. It's going to store 2 different things. And I'm drawing then a vertical line for a column, but I'm making the left-hand column much skinnier than the right-hand column, because the left-hand column only needs to store that data that we already put on the network. This is one style of graphical analysis for project management. We find it pretty handy. In general, how it works, that's the activity, right? This is the label. I'm using Z here just because it doesn't have anything to do with down here, right? That's the duration. This is where we'll put the early start time. This is where we'll put the early finish time in that upper row. Okay, now that's just example. That doesn't have to do with anything to do with the San Diego Convention Center project, because we were talking about this network doesn't have a Z in it anywhere. And we were saying that if you are attached to the starting node, we already know what your early start time is. It's automatically 0. You could start on these two projects by definition right now. Oh, okay. So, well, fine. Now, what's the next step? Because we have to fill in that top row for all the tasks. Well, the next step is pretty intuitive. Go back and look at the two tasks that are attached to the starting node. In the case of A, the earliest we could start on A is right now. A is, I'm just reading the information on the network. It's 1 day's worth of work. That means that the earliest we could be finished with it is in a day. If we started right now, we'd be done in a day. With B, it's 3 days worth of work. If we started right now, we'd be done in 3 days. So the early finish time is 3. Now, this is, you can treat this as a formula if you'd like. Right? It's really just logic, but you say, huh? How'd you get the 1? How'd you get the 3? Well, this is what I did. Early finish time equals, it's just logic, your early start time plus your task time. When you finish is when you start plus however long it took. Oh, okay. Now, moving on. I'm looking at the network. I'm looking at the network, and I noticed, just reading the network, that both E and C have A as an immediate predecessor. This is actually, if you want to look it up in the original scenario, creating the drawings. C is, for instance, building the stage. Okay, the drawings have to be finished before you can build the stage. We have just found out that the earliest that we could finish the drawings, that's task A, is in 1 day. Pass that number forward. That becomes the very earliest we could start building the stage is in 1 day because it's waiting. And the same thing with E. If the earliest we could finish A is in 1 day, pass that number forward. That's the absolute earliest. If we're in a hurry, we don't leave any gaps. It's the absolute earliest we could start on this task. Now the arithmetic. Okay, task E is only 1 day long. So at the earliest, if we started on it in a day, 1 plus 1, we might be finished with it at the earliest in 2 days. In the case of C, 1 plus 4, the earliest we could possibly be finished building the stage is 5 days from now. Who else? Oh, I'm looking at D. D cannot be started until, what's the arrow mean? B is finished. B could be finished at the earliest in 3 days, so pass that number forward. D could start at the absolute earliest in 3 days. 3 plus 2 is 5. The earliest it could be finished is also 5 days. I'm looking at F. F could start, that F is painting the stage. F can start as soon as C, building the stage, is finished. Okay, building the stage will be finished at the earliest in 5 days, so that, pass the number forward, is the absolute earliest we could start painting the stage. 5 days. 5 plus 2, the absolute earliest we could be finished is in 7 days. Okay, and we just keep filling these out. Now I'm looking at G. I'm looking at G, and careful, I'm looking at the network. And do you notice that G has more than one immediate predecessor? Everything that we have dealt with so far only had one arrow pointing at it. But G cannot be started until F and D are finished. Now, we've just found out that F could be finished at the earliest in 7 days and D could be finished at the earliest in 5 days. And the question is still the same. What's the absolute earliest we could start on G? It's waiting on both of them to finish. When you have a choice, think about it. You have to wait for both of them to finish. One could finish at the earliest in 5 days and one could finish at the earliest in 7 days. They both have to finish before you can start. Logically, what is the earliest that you can start? Well, you'd have to wait around for the 7-day one, right? Yeah, pick the largest. That means that G, at the very earliest, we could start on that in 7 days, and then just arithmetic, 7 plus 1 is 8. Its early finish time is 8. And the logic that we used to come up with that 7 right there, that is the so-called early start time rule. It's actually stated on this note page. Early start time rule. The early start time of a task is the largest of the early finish times of its immediate predecessors. When you have a choice, you always pick the largest. When you have a choice, up to this point, we technically were using the early start time rule this entire time. It's just that for all the other tasks, there was only one other immediate predecessor, so it didn't matter that it was the larger or the smaller because there was only one. Okay, now, continuing on, because we're not finished finding all of them. H looks a little more straightforward. H only has one arrow pointing at it. We trace that back. Oh, that's G. G could finish at the earliest in 8 days. Pass that number forward. Then H could start at the earliest in 8 days. 8 plus 1 is 9. That means that task H could finish at the earliest in 9 days. Great, there's only one more to do here, and then we'll have found all the early start, early finish times. All right, I. Oh, careful. I is another one in which there are 2 arrows pointing at it in the network, indicating it has 2 immediate predecessors. I cannot start until E and H finish. E could finish at the earliest 2 days from now. H could finish at the earliest 9 days from now. We always pick the larger of the 2. We're waiting on both of them. Well, then I could start at the latest, or could start at the earliest, start at the earliest 9 days from now. 9 plus 1 is 10. The absolute earliest that I could be finished is 10 days from now. All right, at this point, we have that first question. We have found the early start, early finish times. For any one of the tasks, just look it up. We have it. That there was 2 questions. The second question was, how much time will be required to complete this project? At this phase in the analysis, when we have found all the early start, early finish times, we actually have enough information to answer that question. How long is it going to take Epic Scenic Studios to do this stage at the San Diego Convention Center? How do you find it? You go to the finish line. Go to the finish line and look from the finish, trace backwards every task that's attached to the finish, which for us, oh, that's boring, it's only one task. Fine. What is the earliest that task will finish? You say, well, the earliest that task would finish is in 10 days. That 10 right there? Fantastic, that's the answer. Why? Because task I, being the only task that's associated with the finish line, is apparently the last thing we will be doing in this project. The very earliest we could finish up that one last thing is in 10 days. That is telling you that the very earliest we could be finished with this project is in 10 days, because a project is not finished until all its component tasks are finished. Now, wait a minute. What if there had been more than one task attached to the finish line? Oh, that's not too much more complicated. Well, you'd have like 2 or 3 different early finish times then, right? What do? It's the same thing as the early start time, early finish time rule at the bottom. Just pick the largest, right? You would be waiting on all of them to conclude. Pick the largest. That would be the duration of your project.